So today we are going to start with Euclid's geometry. Okay, in Euclid's geometry, as I told you, it is all theory. Okay, it's some of the Euclid's in here. We will find some Euclid definitions. Okay, some common definitions from all total. Good evening, Anna. All total Euclid gave 23 definitions.
I was late. I had another class.
Okay,
Right
I know.
before this.
We have started just now only because it's 5 only. So there are 23 total of 23 definitions. From that, here you will find 7 definitions, and from all his postulates and axioms, we are going to. I'll be telling you about five postulates. We'll cover 5 postulates and 7 axioms. Okay. So let's see. Basically, first of all, geometry. Geometry means about the measurement of your earth. Okay, geometry is where you use generally in your architecture, in your construction. Okay, what should be your you can say all the constructions work. Okay, we draw it in your diagrams on whenever you have you seen or do you know about that whenever a building is created, us architects actually design it, the sketches in the copy or in papers. Okay, and there are the measurement, and through that only they try to build it. So all this architecture design, how they build it from the help of these geometrical all those concepts and all. Okay, from some of the basic trigonometry. Okay, when you study about the height and distance, then also you will come to it. So these are, you can say, the applications or where your maths is actually used. Sometimes we feel that where all these things are used. Okay, trigonometry you're not going to use after 12th apart from you're using apart from your mathematics. Okay, but it is not like that. Okay, when you go for higher study or where it is actually used, there so much usage are there. Okay, so let's see about the Euclid's definition. That what is the definition of Euclid? Okay, a solid has shape, size, and position. That everybody knows. The common things are here only. Okay, that you already know this, the basic things, or you can say a common sense thing. Okay, that you have been already watching it and you have been already applying it. Okay, a solid has shape, size, and position. Also, it can be moved from one place to another. Already we know that a solid has shape, size, and position, and we can move a solid object from one place to another place. Okay, it has boundaries. Okay, how a solid is visible? Actually, it is having all the boundaries that are that you see. Okay, which are called surfaces, which separate one part of the space from another, and a set have no thickness. Okay. So now if you see a two-dimensional thing, or if you see two pens also, okay, because of these boundaries, because of the boundaries, they are two different things. Okay, if they don't have boundaries, then they are mixed. Okay, a paper, a single paper, if you take, so it will be two. If you tear it into two, so it gets two different boundaries, so it becomes two. Okay, so you have boundaries which separate it from each and every other object. Okay, the boundaries of the surface area curves a straight line. These lines end at a point. Whenever we draw a line, there is an end point to that. Okay, two end points are there. To single line, one is you can say both sides they are end points, and if there is an it's a ray, so you can exceed that line on both the sides. Okay, thus there are 3 steps from solid to points: solid, surface, lines, points. In each step, we lose one extension, which is dimension. A solid has 3 dimensions, a surface has 2 dimensions, a line has 1 dimension, and a point has no dimension. I think you already know. See, when every step you move, so you are losing 1 dimension. Okay, how? Just a minute. Wait for just 1 minute, class. Okay, just one. Sorry, actually, some question paper issue was there. So just okay. So what I was telling that, yeah, whenever we move from the main level, that is the surface, from the solid. Okay, from solid, when we move to the surface, we lost 1 dimension. For a solid object, if you see, it is in the space. Graphics, yeah, with a solid, if you see, so it is in the space. Okay, so you have 3 dimension, all the 3 dimension, x, y, and z. Okay, but when you see in the surface, the same thing on a surface, if you see on a paper, then you lose 1 dimension and it become 2 dimension thing. Okay, and when you just take a single line, again you lose 1 dimension and it is only a single dimension thing. Okay, and again from a line, if you see just single point, so again dimension is lost and you see only dimensionless object. Because a point, when you join so many points, then you create a line. When you create so many lines, then you create a surface. And when you join many surfaces, then you have a 3-dimensional figure. Okay, a cube has how many surfaces? Okay, so Euclid's definition. Okay, just simply, Shazan, you see that. Okay, like a cube. Okay, just take a cube. Okay, a cube, an ice cube, or a dice. Okay, imagine a dice. It has how many surfaces? 6 surfaces.
Yes, ma'am, 6.
Okay, yeah, 6 surfaces, and it is a 3-dimensional figure. Okay, when you take the dice into a copy, okay, a simple square, a single surface if you take, so it is a square, and it can be drawn on a paper, okay. So that is a two-dimensional figure, okay, because you cannot see it in the space, it is on the paper, so that is only a two-dimensional figure, x and y, okay. So what, when you move from cube to space, from a space to the surface, then you lost one dimension, okay. From 3 dimension, that object became 2 dimensions, so you lost 1 dimension, okay. Now again, how many lines are there? There are so many lines. When you add all those lines, then a square is drawn, okay. In fact, there, to draw that, 4 lines are used, okay, in a proper way, okay, 90-degree angle, 4 lines are used, then you can get a square, okay. If you take a single line, then again you lost 1 dimension, because a line is a single dimension, okay. Now a line, there are so many points. When you draw so many points and you attach all of them, then you get a line, okay. So if you choose a single point from that line, from anywhere, from the bottom, from the last, from the middle, anywhere, if you take a single point, so it is a dimension less, okay. So you again lost a dimension, okay. Now main thing that you have to focus here, that some of the basic definitions that the Euclids gave, okay. So Euclids gave total of 23 definitions. From all those 23 definitions, here we are going to cover 7 definitions, okay. Now the main definitions that you are going to cover here, that are about point, surface, line, your edges, all, okay. The first definition, if you see here, and enlarge just a little bit, okay. If you see the first definition, a point is that which has no part, okay. A point is that which has no part, that is, a point is an exact location, okay. When you draw a point, that is a single thing, okay, single dot, okay. So that is telling you an exact location. Yes, it does not have a huge line. There's so many joints of points. So a line is that which has no part. It does not have a part. It's the smallest part you can say in geometry, okay. Like in your chemistry, you can say neutron, proton, electron. In fact, smaller than them also there, but we generally take electron, proton, neutron, okay. Atom, smallest unit. Here, the smallest unit of all your lines and surfaces, everything, the point is the smallest, okay. So point has no part, okay, and point is an exact location. Now from point, if you move ahead, up or aage badhte ho, so you get a line. So a line is a breadthless length. Breadthless length, I'm said that because if you draw a rectangle or a square, so there's no breadth, okay. So line is a simple length, okay. It is just talking about your length, okay. So it is a breadthless length, no breadth is there, okay. In that way, Euclid gave the definition, okay. The ends of a line are points. The ends, when you see the end of the line, they are points, okay. In fact, a whole line is drawn with the help of so many points, but you see at the end, they are also the points, okay. A straight line is a line which lies evenly with the points on itself, okay. Straight line, how? See, if there are so many points, okay, here and there, and if I join all the points, it is not a straight line, okay. This is not a straight line. For a straight line, all the points should be on a single, you can say, evenly, which lies evenly with the points on itself, okay. So a straight line is a line which lies evenly with the points on itself. A surface is that which has length and breadth only, okay. A surface is that which has length and breadth, okay. Length and breadth both, okay. Now the edge of a surface are lines. The edge of a surface are line. The plane surface is a surface which lies evenly with the straight line on itself, okay. जो plane surface होता है आपका is a surface which lies evenly with the straight lines itself, okay. Now these are the definitions stated above. There's some like parts, breadth, length, etc. और deep में नहीं, मतलब ये basic definitions जो है, from 23 definitions we have picked these definitions from the Euclids, okay. Now what are axioms and postulate? Okay, we will be covering the Euclids axioms and postulate. Now there are two things. Now, stating with this definition, Euclid assumed certain properties which were not to be proved as there were universal truth. He divided his assumption into 2 types, okay. They doesn't need a proof. Some things are universal truth, okay. You don't need to prove it, okay. So these Euclid's axiom and postulate are universal truth that need not to be proved. Now, again here you can see 2 things. 2 names are here, postulate and axiom. Now, what is the difference between postulate and axiom? Let's see. Postulate. The term postulate were used for the assumption specific to geometry, okay. Those assumptions that were only specific to geometry, that is only used for the geometrical purpose, they are called postulate, okay. Actually, postulate is a verb which can say, let us postulate, when we mean that the main thing that you have to run if it is truth valid from here based on the observed phenomena in the universe, and then check if it is truth or valid. Okay, if it is true or valid, then it is accepted as a postulate, otherwise no. Now some of the universal truth that you see around you, you take it as a postulate. Okay, and after taking it as a postulate, you check that is it true or valid or not, and if it after checking, if you find that it is true or valid, then it is accepted as a postulate. Okay, and postulate are mainly specific for your geometrical purposes. Whereas axiom, the term axiom was used throughout mathematics and not specifically linked to geometry. So axioms are not only specific to geometry, your algebra also will use it, and your the different arithmetics will also use this axiom. But postulate, they are only for the geometrical purposes. Okay, for the based on the figure purposes. Okay, like where you are using line, surfaces, circle, these type of related to the shapes and all. Okay, so postulate are related to geometry, and axioms throughout mathematics you are going to use. Okay, that is the only difference between axiom and postulate. Now Euclid axiom. Okay, now we are going to cover how many axioms? 7 axioms. Now you have to remember all the 7 axioms. Everybody, you have to learn them by heart. Actually, they are all common, but the main statement. Okay, and based on them only you'll find some basic you can say exam questions. Okay, this chapter is not going to cover very much. Okay, only this axiom and postulate are there, that much. Okay, so the first axiom: things which are equal to the same thing are equal to one another. Now what does this mean? Things that are equal to same thing are equal to one another. Okay, now if I say that A is equal to B, okay, A is equal to B. Now I say B is equal to C. Okay, so from these two statements, we conclude that A is equal to C or
A
not.
is equal to C also.
Yeah.
A is equal to C also.
Yeah. So that is only this statement is saying that things which are equal to the same things, वो चीजें जो same चीजों के equal है, equal to one another. That means that if A is equal to B and B is equal to C, so A will be equal to C. Okay, understood? You can see here a line segment. Here you can see a dash. That means a line. It is talking about a line. That if AB line segment is equal to CD line segment and CD line segment is equal to EF line segment, that means AB line segment is equal to EF. Okay, so this is a general truth that we have been using till now. Okay, you don't need an extra proof for this statement. Everybody is using or not this statement. I think throughout mathematics we are using it whenever we prove x is equal to y.
This is a very vital thing, but it's
Yeah.
not very much that we think about.
Yeah, it is just a very simple chapter. Okay, it's nothing much deep here. Okay, basic statements are here. You just need to remember. Okay, that's it. Okay. Now, second axiom, if you see here, if equal are added to equals, then the whole are equal. Now, if I'm saying here the next statement that if A is equal to B, okay, if A is equal to B, so it is telling that A and B are both equal. Okay. Now, if I'm adding C, that is equal. If I'm adding C on both the side, will A plus C is equal to B plus C or not? I'm asking a question.
Yes, ma'am. If you're adding C at one side, we need to add on the other side also.
I am adding C on both the side, and since C is already equal to C, so A plus C will also be equal to B plus C because already
whatever we are doing to one side, we need to do it to the other side also. No, ma'am.
Yeah. Okay. But this is the axiom that the Euclid's gave. Okay, that if equal are added to equal, then the whole is equal. Okay, there's nothing tough here, I think. Yeah, everybody, any doubt in these statements?
No,
These are very simple statements. Okay, so an example you can see here: if a measure of triangle angle ABC is equal to measure of angle DEF, then on adding similarly, like for angles also, here it is telling example of geometry. Okay, so in that way also you can use if angle A is equal to angle B. Okay, so if you add angle C here, so this will be equal or not? Because angle C is already equal to itself. Okay, and angle A is already, and from the first statement, angle A is equal to angle B. So angle A plus angle C will be equal to angle B plus angle C. Okay, now let us see some more axioms. Okay, total 7 axioms are only there. Okay, now third axiom: if equals are subtracted, the same thing. Now before this we have added equals to equals. Okay, so the whole was equal. Now, if equals are subtracted from equals, then the remainder are equal. Okay, so if I write A is equal to B, then A minus C will also be equal to B minus C. Okay, because same thing I'm subtracting on both the sides. Okay, in fact, whenever we are trying to prove anything, or certain times we try to simplify things, then we add the same thing on both sides. We subtract on both sides. We multiply, same thing on both sides. We divide from both sides. Or numerator, denominator, we do the same thing. Okay, things which coincides with one another are equal to one another. Now coincides. Okay, things that which coincide with one another are equal to one another. That means that if a line, for example, a line, you can see a line here, AB. Okay. Now, if there is another line, PQ, in such a way that it is overlapping this AB. Okay. Imagine that this is overlapping. This is coinciding on AB. So they both will be equal or not. अगर एक चीज दूसरे को बिल्कुल ओवरलैप कर रही है या कॉन्साइड कर रही है तो वो इक्वल होगी कि नहीं?
Yes, ma'am.
Yeah, so it will be equal. The same thing it is telling you here.
AB equal to
Equal.
Yeah, AB will be equal to PQ. So things which coincide with one another are equal to one another. For example, if line AB coincide with PQ such that A falls on P, now it is a proper explanation is given that A in such a way that A falls on P. जो A point है वो P पे fall कर रहा है और जो B point है वो Q पे fall कर रहा है. That means that AB line segment AB is equal to line segment PQ. That is, if two things are identical, then they are equal. In other words, everything equal to itself. Okay, obviously if the point A is coinciding on P and if B is coinciding on Q, so actually they both became the same thing. Okay, understood?
Yes, ma'am.
Okay, now the axiom 5, the whole is greater than the part. That everybody knows. अगर हम कोई चीज full glass of water ले, if we are taking full glass of water, will it be greater than or not from a half glass of water or a 3/4 glass of water? Yes or no? It will be greater. So when the full is always greater than the part. Okay, whatever part you are taking, 1/4, half, 3/4, okay, 9/10, whatever part you are taking. But always the full will be, there's a statement, the whole is greater than the part. Okay, this is a general statement. Example, it is written here, if x is equal to y plus z. Example, x कैसे बना हुआ है? Y plus z. So x is containing both the things. Okay, the whole x is a sum of y and z. So and y and z is not equal to 0. So x will be always greater than y and x will always greater than z. Yes or no?
Yes, ma'am.
Because it is the sum of y and z. Whether, for example, if I say that x is equal to 10, okay, and y is equal to 9 and z is equal to 1. So x is equal to y plus z. Is still, you can see y is equal to 9 only. Still, and actually the condition was y and z should be not equal. So still x will always be greater than y also and x will always be greater than z. Okay, x is the whole. Okay, so whole is always greater than the part. Now, things which are double of same thing are equal to one another. Things that are double of the same thing are equal to one another. So it is written that, for example, okay, if x is equal to 2a, okay, and y is also equal to 2a, okay, both the things are equal to double of same thing. So both will be equal to each other or not?
Yes, ma'am.
Yeah, so that only it is written in the statement form. Things which are double of the same thing, वो चीजें जो दूसरी चीजों की दुगनी है, so the same are equal to one another. Okay, so things that are double of same thing are equal to one another. And this statement is little bit modified. Things which are half of the same thing are equal to one another. That is the seventh axiom. Okay, that means if your x is equal to a by 2 and y is also equal to a by 2, so x will be equal to y or not? Yeah, because they are half of the same thing. You can see here y is equal to x by 2, z is equal to x by 2, so y is equal to z. Okay, these are the 7 axioms. In fact, there are many more axioms of Euclid, but you have to cover in your class only these 7 axioms. So were they difficult?
No, ma'am.
No, they were all the general statement that you have already been using. Only
Ma'am,
you
it's
just
like,
have
ma'am, it's just so easy. It's like the basic thing.
yeah, basic thing in fact. Okay, so you just have to remember the statements, because when you are the questions that will come here, you'll have to mention from which axiom. Okay, from axiom number 1, or you can write the whole axiom also. So you have to remember the statement in which way it is written. Okay, this is theorems hote hai na. When you are using theorem, you should remember that you have to learn by heart that theorem. What would you mean statement hota hai that you have to learn it. Similarly, you have to learn the axiom. Okay, and in fact, when you will read 2-3 times, they are called basic one. Okay, now let's see 1 or 2, 3 questions based on the axiom, that what type of question will come. Okay, now example number 1, if you see in the given figure, it is given that angle 1 is equal to angle 4. So angle 1 is equal to angle 4. This is given to you, and angle 3 is equal to angle 2. Now this is also given to you. Which Euclid's axiom it can be shown? But statement can by which Euclid's axiom it can be okay. By which Euclid's axiom it can be shown that if angle 2 is equal to angle 4, now another given is there, angle 2 is equal to angle 4. Then which axiom you are going to use to prove that angle 3 is equal to angle, wait, I'll copy. So Okay, now if you see here, okay, so it is given that angle given angle 1 is equal to angle 4, angle 3 is equal to angle 2, and angle 2 is equal to angle 4. Now you have to prove to show angle 1 is equal to angle 3. From which axiom? You have to tell angle 1 will be equal to angle 3 or not from all the three givens. See, angle 1 is equal to angle 4, angle 3 is equal to angle 2. Okay, so angle 2 will be equal to angle 4 or not? Yes. Sorry, angle 2 will be equal to angle 4. This is also given. So if angle 2 is equal to angle 4, that means angle 1 will be equal to angle 3 because angle 2 is equal to angle 4. Okay, and angle 4 is equal to angle 1. So that means angle 1 will be equal to angle 2. Okay, from this angle 1 will be equal to angle 2. Okay, and angle 2 is equal to angle 3. So angle 1 will be equal to angle 3. Yes. And from which axiom I am going to
equal to angle 2.
see, Shazan, what is given here? All the three are here given. Okay, so you have to show that angle 1 is equal to angle 3. See, since angle 2 is equal to angle 4. Okay, so if angle 2 is equal to angle 4, that means what? 1 will be equal to angle. What you have to do? 1 will be equal to 3 now. So 2 is equal to 4 and 4 is equal to 1. So that means angle 2 is equal to angle 1. Okay, or you can say angle 2 is also angle 2.
Angle 3 also. So angle 1 is also 2 equal to angle 2. So angle 1 is, can also be equal to angle 3.
Yes. So now which axiom you have used to prove this? Tell me that.
The first one.
Which axiom? Axiom number?
1.
Same will be equal to, yeah, axiom 1. Okay. Axiom 1 said what? Where was your axiom 1? That if the same is equal to, things which are equal to the same thing are equal to one another. Okay. So we use axiom 1. Okay. Now, wait. Yeah. Now, same question. If you see, it is all same and all. Okay. So, two salesmen make equal sales. Okay. Two salesmen are making equal sales during the month of June. So, in the month of June, the sales are equal. If he is earning, the one salesman is earning X, then the other salesman is also earning X. In July, each salesman double his sale of the month of June. So, in the month of July, their sale was double of the month of June. But since they both earned the same in the June, so that means this time they are earning 2X. Both are earning 2X. Okay. Compare their sales in July. Now you have been asked to compare the sales in July. State which axiom you use here. Also give two more axiom other than the axiom which in the above statement. Now mainly I think the sixth axiom is used here. The sixth axiom says that things which are double of the same thing are equal to one another. Yes or no? And in the month of June they were earning same thing. Yeah. If they're earning same, so that means if salesman 1 is earning X, so salesman B is also earning X. But in the month of July the sales were double of the June. So that means
they both 2X.
Yeah, both earn 2X. Now, if you will compare their from June to July, so which axiom is used here? That they both are equal. They are equal. Axiom number 6, which state that things which are double of the same thing are equal to one another. Okay. Now, it is asked you that state two more axiom other than the axiom used in the above situation. Now, two more axioms can be what? The two more axiom other than the axiom 6 are axiom 2 and axiom 3. How axiom 2 and 3? 3, it says that if equal are subtracted from equal, then the remainder is equal, and the 2 states that if equal are added to equal, then the remainder are equal. Okay, so if double of 2, that means X plus X. Okay, so they earn in the July, they again earn another X. So X plus X they earn in July, and both of them. So that is, we are adding the same quantity. Okay, so axiom 2 is also used, and you can say axiom 3 also. Okay, so have you understood that which type of question are going to come? A picture has been created in your mind that what type of question will be asked. This simple question will be asked. You just have to say that which axiom, or you have to tell that by which axiom you are proving it. Okay, that's it. Okay, now if you see example number 3 here, in the adjacent figure, you can see a line here. Okay, let me copy. Okay, now what is the problem here? Wait, I'll just resolve it. Okay. Now, if you see a question here, let's see. Now, if you draw the diagram for this question, okay. This is your M, and where's A? This is A, M, and C. A, M, B, N, C. Okay. Now, what is here written in the adjacent figure? If AB is equal to BC. Okay. Now, it is given that AB is equal to BC. Okay. Your AB is equal to BC. M is the midpoint of AB and N is the midpoint of BC. Now, M is the midpoint of AB and N is the midpoint of BC. If M is the midpoint, of AB, therefore, अगर M आपका midpoint है, that means AM is equal to half of AB or not. In fact, AM equal to MB and this is equal to half of AB. Yes? Am I right? Yeah. And similarly, N is the midpoint of BC. Am I right? Yeah, BC. Therefore, BN is equal to NC is equal to half BC. Okay. Now, let's see the second part. And our second part, the first part only. Show that AM is equal to NC. Now, it is asked you to show that AM is equal to NC. AM is equal to NC. Now, can you show that AM is equal to NC? Now, if you write AM or NC, okay? So, AM, it is already given that AB is equal to BC. Yes? I will just delete this. Okay, if I write here that AB is equal to BC. ये आपको given है. Now, if you do the half on both the sides, AB is equal to half BC or not? Yes or no? We already know from the axiom number 6, from 7, axiom 7. Okay. Now, half AB can be written as which thing which you have to prove? AM. And half BC can be written as NC. Yes or no? Yes. Similarly, let's see for the part second. If BM, now this is now in the second part is telling that BM is equal to BN. Okay, then M is the midpoint of AB and N is the midpoint of BC. Show that AB is equal to BC. Now this time it is just reverse. Okay, the first part that we have done, it is just the reverse of the second part. Now in this, it is not given that M and N are the midpoints. Now you have to prove that M and N are the midpoints. Okay, it is given that BM is equal to BN. Okay, now if it is given that BM is equal to BN, now let's see, let's prove here that BM is equal to BN. Okay, now if BN is equal to BN, then M is the midpoint of AB and N is the midpoint of BC. Show that AB is equal to, BM is equal to BN, then M is the midpoint and N is the midpoint of BC. Both are given. Sorry, both are given. You just have to show that AB is equal to BC. Okay, so if BM is equal to BN, and we already know that it is the midpoint. Okay, so BM can be written as what? BM can be written as half. Okay, or you can say, you can write here half directly. Okay, you can just directly write it as half AB. Okay, half AB is equal to half BC. Okay, now if you are going to cancel that this half and half, so you'll get AB is equal to BC or not. Okay, so AB is equal to BC, or you can say that in fact if M is midpoint, okay, if M is midpoint, that way also you can prove is M is midpoint. So AM is equal to MB. Okay, so AM plus MB is equal to AB. Similarly, BN is equal to NC. So BM plus NC is equal to BC. Okay, and AM is equal to it is given what? BM is equal to BN. Okay, so from this whole will be equal. You can write the two of it. Okay, so BM is equal to what it was written? BM is equal to BN. BM is equal to, or you can say BM. Okay, so instead of this, you can write here this equation. Since they both are equal, M is the midpoint, so you write 2BM is equal to AB. And from here, both are equal, so you write what is asked you to prove? BN. So BN, this is N. BN, 2BN is equal to BC. Okay, so 2BM is equal to 2BN. Okay, double is equal, and 2BM is equal to AB, and 2BN is equal to AC. Okay, everybody? Any doubt in this or confusion in the second part?
No, ma'am.
And Razi, anyone? Advika, anything? Sharia, any doubt?
Oh, ma'am, can you explain me the second part?
Yeah, of course. See, wait, I'll show you here. Okay, I'm writing the whole part here. Okay, now, Razi. Okay, so there were 3 points. Okay, it was A, M, B, N, and C. Okay, now it is written to you in the question. You will see here. Let me copy this part. Okay, I'll write this part here. Okay, so what it is given here? Razi, BM is equal to BN. Okay, Razi. So what is given?
Yes.
That BM is equal to BN. Okay. Now it is also given that M is the midpoint of AB and N is the midpoint of BC. You have to show that AB is equal to BC. Okay, Razi. Now if M is the midpoint, if M midpoint, therefore BM is equal to AM. Yes, which is
Yes,
equal to AB. Yes. Okay. Or you can say in fact that AB is equal to 2BM or not.
Yes, ma'am.
Okay, BM, this part BM is equal to AM. Okay, and this AB is equal to and this BM is equal to half of AB. Okay, or you can write that AB is equal to 2BM because BM and AM are both equal. Similarly, BN is equal to NC. Okay, so I will write here N midpoint. Midpoint. Therefore, BN is equal to NC is equal to half ABC. Okay, or you can write that BN is equal to 2BN is equal to 2BN is equal to ABC. BC. Okay. So now it is given that BM is equal to BN. Okay. BM is equal to BN. It is given. So in fact, you can write that 2BM is equal to 2BN also because the things are equal, then the double will also be equal. Now 2BM is equal to what? From equation number first and second, if you will see that 2BM is equal to AB and 2BN is equal to BC. Understood, Razi?
Yes, ma'am.
Okay, very good. Now, these types of question will only come here. Okay. Now, if you see question number 4, in the given figure, if angle DOB is equal to 87, okay, DOB, okay, you can see I have marked this 35, BOA I have marked 30. Now, the rest two of the angles sum, that is DOC and COB, both of their sum is 87 degree because it is written that given that angle DOB is 87 degree. Okay. Now, angle COA is 82 degree and BOA is equal to 35 degree. Okay. Now find COB. COB it is asking you and COD separately. Okay. Now I'll just draw the figure here only. Okay. Only figure I'm drawing. What is okay. Just a minute. Okay. Now if I draw the figure here, a bigger figure I'm drawing. So that is very much clear. Okay. Now this is D, C, D, A, and O. Okay. Now it is given that this angle is equal to 35 degree. And what is DOB? DOB. I'm using different color so that nobody get confused. That DOB is equal to 87 degree. Okay. Now which angle is more given? COA. COA. This angle is given as 82 degree. 82 degree. Now what you have to find out? Angle COB. Okay, COB you have to find out. COB. This angle you have to find out. Okay, and which angle else you have to find out? COD. COD. This angle you have to find out. Which color now I used? This color I'm using. Okay, now the other angle that you have to find out, that is this. Any confusion in the diagram? Okay, now if you are finding COB, so angle angle COA is equal to angle COB plus angle BOA or not? Everybody, just check the diagram. Angle COA is equal to angle COB plus BOA or not? Yes?
What, ma'am? Can you repeat?
See what I have written. Angle COA, this is the blue angle. The blue I have marked, that is 82, will be equal to the yellow one and the red one. That is COB plus BOA. Okay. So now COA is already given. COA is given as 82 degree. So 82 degree is equal to COB is not given. COB plus BOA is 35 degree. Now you can find out the value of angle COB is equal to what? 82 minus 35. So what will be the value? 47 degree. Okay. Any doubt? Okay. Now the next that you have to find out is this one. This angle. Okay. I'm writing with different color. This one. Okay. Okay. Now if you see here, yeah, angle DOB. DOB is given or not? Yeah, DOB is equal to angle DOC plus angle COB. COB. Yes. And DOB is already equal to 87 degree. Okay. Plus DOC. DOC we have to find out. And COB we have already calculated. That is 47 degree. Okay. So yeah, this will be equal to angle DOC plus 47 degree. Okay, so angle DOC will be equal to 87 degree minus 47 degree. Oh, 470, it's looking like 47 degree. Okay, so it will be what? 40 degree. Okay, now any doubt? So that means this angle we have got as 40 degree and this angle we have got as how much? Sorry, yeah, 47 degree. Any doubt now? Anybody?
No.
Any doubt? Okay, so we are ending here only because it's almost 52. Okay, so we have completed till here. What is else there? Postulate. Okay, so in next class we'll be covering about the postulates. Okay, axioms we have covered. Okay, everybody revise all the axioms. Okay, so you have only 7 axioms. Okay, revise all of them and okay, understood? Any doubt in any of the question? Anything? Any axiom?
No, ma'am.
So till then, till the next class. Bye bye.